I have the pleasure to invite Richard Kerner, who is a professor from Paris, to give a presentation for the role of humanities in scientific creativity.
Thank you very much. Искам да благодаря организаторите на тази конференция. Аз забравих малко български язик и за ваше позволение направя презентация на английски. So I'll speak in English. So the topic is the role of humanities in scientific creativity. The aim is to show the profound influence of humanities, philosophy, ethics, law, and theology on scientific interpretation of reality. While the exact scientists explore the observable world, humanities explore the observer. Starting from the antiquity and throughout the Middle Ages, science was entangled with philosophy and religion, which shaped the worldview of all major thinkers, even those who were opposing currently admitted dogmas. Here I just show the tree. It is a symbol of how deep the roots of our knowledge are, and they're invisible, but most of them go back to philosophers and human scientists in antiquity and Middle Ages. The very term humanities was introduced during the Renaissance to underline the separation from divinity studies, it is religion, and humanities defined as academic disciplines that study aspects of human society and culture, including certain fundamental and existential questions asked by humans. They cover philosophy, religion, history, and language, literature, writing, oratory, rhetoric, and poetry, performing arts, theater, music, dance, and visual arts, painting, sculpture, architecture, and more recently, even photography and filmmaking. Now I wanted to share with you my thoughts about the similarity between the relationship between humanities and scientists to what physicists know in thermodynamics, the difference between energy and entropy. The first law of thermodynamics established the energy conservation, but it does not give any hint about the direction which thermodynamical processes are supposed to follow. This is established by the second law of thermodynamics, stipulating that the entropy must always increase, and this gives the direction of thermodynamic processes. Similarly, scientific endeavor gives us the clues about the mechanism and functioning of material world, but it cannot answer questions about the ultimate sense of our own existence. So now it is, as an intermezzo, I wanted to share with you an anecdote, a historical anecdote, about Cauchy and Lagrange. Cauchy, the great French mathematician, and Lagrange, even maybe greater. So when the future famous French mathematician Augustin Louis Cauchy was 13, his father, having noticed young boy's extraordinary mathematical gifts, presented his son to Joseph Louis Lagrange. Then at the top of his fame, he was, I think he was president of French Academy at this time, and asking whether he could recommend entering the university at once, skipping the last few years of high school, the lycée in French. And Lagrange's answer was categorically no. He argued that only after getting full classical education, including Latin, ancient Greek, history, and philosophy, young men will be able and will be ready to start mathematical and scientific studies. By the way, young Cauchy returned to high school, and at the end of high school diploma, he got the first prize in humanities. He wrote a very beautiful memoir on history in Greek, and he mastered Greek and Latin. So by doing this, Lagrange followed the millennium tradition of European educational system, inherited from ancient Greece and Rome, and which acquired its final form during the European Middle Ages. A man of the 18th century, Lagrange was himself a prodigy, not only in mathematics, but in other matters as well. He corresponded with great Euler in Latin, mastered ancient Greek as well, and was fluent in principal European languages. Sorry. Yeah. The idea that a solid linguistic erudition in literary and historical culture must precede more specific studies was inherited in Europe from Greek and Roman antiquity. By the way, a similar approach to studies was practiced also in China, where to become a Mandarin, one should learn ancient poetry and literature first, before the study of law or medicine. Long before the fall of Roman Empire, Christianity became its official religion, and gradually, after several centuries of invasions and political instability, the educational system was in the hands of the Catholic Church. Thus, science and religion became intimately intertwined for many centuries to come. During the Middle Ages and until the 18th century, the elementary education was ensured by Catholic priests, of which Jesuits were the most illustrious company. Now, the studies were divided in two big parts. The trivium, from which nowadays the word trivial comes, I mean the fundamental, the elementary, consists of grammar, logic, and rhetoric, three matters, while the quadrivium consists of arithmetic, astronomy, music, and geometry. So today we would say geometry and algebra, astronomy and music. Together, they constituted the 7 liberal arts, which were supposed to lead students to see a unified idea of reality. It is the world around us. These skills were called liberal, meaning free, because they involve a purely intellectual activity, as opposed to skills demanding manual work, like sculpture, painting, architecture, ceramics, and so on. Here is a nice painting by Henri de Vulcop in the 15th century. And you see there are 7 feminine characters led by science towards a great priest or something like that. But here you have 7, 1, 2, 3, 4, 5, 6, 7 liberal arts. Each of the characters carries something in hands that symbolizes the one of the 7 arts. Now, the 3 fundamental matters of the trivium course were clearly intended to learn how to express one's thoughts and feelings in writing. In other words, to write properly. This was grammar. Now, to learn how to express the same and how to argue, it is to speak properly, rhetoric, and learn how to distinguish between true and false statements and how to draw right conclusions and assessments from postulates and axioms. In other words, how to think properly. This is logic, which was called also dialectics at that time. And I must personally, I regret that nowadays these 3 things are somehow skipped or postponed in the elementary education. There's no rhetorical logic, much less grammar. The medieval universities in Europe, for which the most ancient one, the University of Bologna, served as a model, had 4 faculties. Students began at the Faculty of Arts, after graduating from which they could continue at the higher faculties of theology, law, or medicine. In principle, scholar establishments got the right to call themselves university only when they hosted all the 4 faculties, including theology. So most of our universities now, in the medieval sense, do not deserve this title. The Faculty of Arts took its name from the 7 liberal arts, as I said before, grammar, rhetoric, and so. In German, Scandinavian, Slavic, and related universities, it would more often be called the Faculty of Philosophy nowadays. And the degree of Magister Artium, Master of Arts, was given by the Faculty of Arts, while the degree of Doctor Philosophiae derives its name from the Faculty of Philosophy, German name of the same faculty. Whether called Faculty of Arts or Faculty of Philosophy, it taught subjects with general and fundamental applicability. The 3 main faculties, the other 3 faculties, medicine, law, and theology, delivered about the same number of diplomas. This was because in any town, people needed a doctor or a pharmacist, a lawyer, notary, and a priest. So you have to cover more or less in the same numbers these three matters. Here I show you the gowns, the doctoral, and there are three types. This is bachelor, this is licentiate, and this is a doctor with three threads and two and only one. And of course, the colors are different for different faculties. So throughout the Middle Ages and beyond, teachings were given in Latin, the universal language of the Catholic Church. Most of the learned people, including those interested in astronomy, physics, and natural scientists, were clerics and often priests. This is kind of unique phenomenon because in other religions, most of other religions, clerics, priests were not that involved in science as in Catholic Church. Latin remained the language of science until the late 18th century, facilitating and encouraging the exchange of ideas between scientists of different nationalities across Europe and beyond. Just like English now. Nowadays, English became the Latin of yesterday. Now, this is an observation that being bilingual and often trilingual from early childhood makes people more open-minded and creative due to greater number of mental associations. And this was practiced, you see, this is the, the first illustrated textbook, the manual of everything, written by, it is called Orbis Sensualium, the world of touchable things, the world of real things that surround us, material things. And it was edited in the early 17th century by, well, in the middle 17th century by Jan Amos Komensky, a great Czech pedagogue. And it is a paragon. It was imitated until now. The illustrated textbook comes from this. And of course, you can see that already then it was delivered in two languages, Latin and German in this case, or other languages later on in later editions. Now, speaking of languages, we should pay tribute to the countless scribes and translators who copied and translated into various languages the scientific and artistic legacy of the antiquity, Greek, Roman, and Hellenistic Egypt. Before they were translated into Arabic, after the expansion of Islam that started at the end of the 7th century, the writings of Aristotle, Euclid, Archimedes, Hipparchus, Ptolemy, and many others were translated into Syriac and Aramaic by Christian scribes, mostly in the Eastern Roman Empire, but also in the Western. And one should know that the papyrus was a very unstable thing. It couldn't last more than 2 or 3 centuries. So when the Arabs started the translations of Euclid or Aristotle, it was almost 1,000 years later. So all these texts were translated and retranscribed by Greek, Roman, and then Christian scribes and translators. And by the estimates of archaeologists, 90% of literature of ancient Greece is lost, in the sense that we do not have even later copies. And 99% of what survived only in the form of later copies, copied many, many times. Now I'd like to make a digression of phenomena of ancient Greece, because we, as you can, except for several things in Arabic, like alchemy and algebra, all other names derive from Greek. Whatever we know in science, it is just Greek names. The Greek philosopher insights were so deep that many questions they asked 25 to 20 centuries ago are still open, although often expressed with different conceptual tools. Is matter infinitely divisible, or does it have a natural limit of size? What are the elementary constituents of matter? What is the nature of time, space, and motion? all this is still, these questions posed by Greeks are still open even now. This is the beautiful painting by Raphael, the School of Athens, with all Greek, mostly except of one or two Arab. There's one or two Arabic wise men, but mostly it is ancient Greeks. Here's, for example, of the same painting is Pythagoras, who is one of the first scientists in Greece, mathematicians and philosophers. I just put on something that this is the use of Pythagoras' theorem, but sometimes it's a very original one. It's called Pythagoras' snail. So you take, first you take the straight triangle, 1, 1, and this is the, as we know by Pythagoras' theorem, this is the square root of 2. Now, if you take the square root of 2 as one of sides and add up on the right angle side equal 1, now this one, the hypotenuse, will be square root of 3, and then square root of 4, and so and so and so, and that will be a snail with always square root of n plus 1. And what is also amazing that we mentioned that one of the quadrivium methods was music, and this started with Pythagoras. This is a unique in human history, that music and mathematics were merged into one. And he discovered, Pythagoras and his school, they discovered the harmony of sounds and scale, natural scale. Of course, this natural scale, I think Professor Popov will speak about this later on. It was based on quints and quarts, but once it could not close after many, many repetitions, you would not got the power of 2, because an octave, you start with the same if you double the frequency. So the tempered, in 17th century, the tempered chromatic scale was introduced, and which played a role in logarithms and exponentials. Here is the example how what is the difference between Pythagorean scale, which is not very equal, as you see, and the tempered scale, which makes all the intervals equal, the chromatic scale. I would like to remind the relationship between music, logic, and graphic arts was very beautifully described by Douglas Hofstadter in his book Gödel, Esser, Bach, which I recommend. Now there's an interesting quote from Whitehead, a famous logician and mathematician. Together with Russell, they authored the book about mathematics, foundations of mathematics. And he said that the safest general characterization of the European philosophical tradition is that it consists of a series of footnotes to Plato. I do not mean the systematic scheme of thought which scholars have doubtfully extracted from his writing. I allude to the wealth of general ideas scattered through them, his personal endowments, his wide opportunities for experience at a great period of civilization, his inheritance of an intellectual tradition, not yet stiffened by excessive systematization, have made his writing an inexhaustible mine of suggestion. And here I will show you some suggestions coming from Plato, which are still actual today. For example, this is a quote from Plato about our soul, about our psyche. Are all our actions alike performed by the one predominant faculty, or are there three faculties operating severally in our different actions? Do we learn with one internal faculty and become angry with another, and with the third feel desire for all the pleasures connected with eating and drinking and the propagation of the species? Or upon every impulse or action, do we perform these several actions with the whole soul? And if you read this, it is almost the what Sigmund Freud introduced, the separation of human psyche into three levels: ego, superego, and id. It's exactly like Plato said, you know, the three different parts of human soul. There's also something that is still actual. It is the Plato's cave allegory. He insisted on the fact that what we perceive with our senses is not is only a shadow, like it can be compared to a shadow of the real, of reality. The real world is probably, she thought it was an ideal world somehow, but the idea that what we perceive is only a shadow of reality is still vivid, because whatever we now are being told that we are in Plato's cave again, because according to modern cosmology and physics, the matter we understand, and all planets, comets, stars, galaxies, black holes, and more, all this is only 5% of the universe, of the energy and matter in the universe. And what is the dark matter and dark energy, we still don't know. It's amazing that still such questions seem to be open. Although for some time, about 100 years ago, people thought that it's almost done, that we know everything. Whatever we observe, there's no other thing behind. And again, the Aristotle idea of elementary constituents of matter originated in the ancient Greece by Thales, Anaximander, Heraclitus, and Empedocles resonates until today. Aristotle introduced the fifth element, later on dubbed quintessence in Latin. It was supposed to permeate the space beyond the sublunar world. And now we are again confronted with something very similar, because we believe, the modern physics believes, that whatever the forces, we have this two types of forces, weak forces and electromagnetic and strong forces, and the fields that intermediate. But according to modern science, to what we believe now, the whole universe is permeated by Higgs field. It is not vacuum, but it's a Higgs vacuum. So we have again something like quintessence, very, very, very close to Aristotle's point of view. Now I come to the Middle Ages, and great thinkers of Islamic world, which were in Islamic Spain, and there was also another school in Baghdad, but it was all in ruins after Genghis Khan's grandson Hulagu sacked Baghdad, and that was the end of it. It was in 1258. And again, Maimonides and Averroes, the great thinkers, one was Jewish and other Arab, and their fate was very similar, because they both born in Cordoba, and they had to flee, because at that time, the Almohad dynasty, which was kind of, now it would be called Islamist instead of Islamic, they took power and they practically stopped all the tolerance and all the scientific endeavor that was before under Almoravid. Now, during the first 2 centuries of second millennium, most prominent European scholars went to Moorish Spain, especially to Toledo, Cordoba, and Sevilla, to learn the 4 parts of quadrivium, mostly astronomy, algebra, and geometry, less music. Also, Islamic medicine, continuing and enriching ancient Greek knowledge of Hippocrates and Galen, was highly praised and studied by European scholars. But things rapidly changed when newly founded European universities, Bologna, Oxford, Paris, and Salamanca, and others, took the lead. Nevertheless, the influence of Averroes was so overwhelming that Catholic Church intervened to condemn the influence that was considered too dangerous for Christians' faith, just as Islamic authorities acted against Averroes and Maimonides, forcing both to exile. Now, the continuation in medieval Europe, the very important thinkers were Pierre Abelard, it's just the 11th century, and 11th and 12th century, and William of Ockham, it was in 13th and 14th century. The medieval scholars explored the structure of our thinking, the language and logic. They provided a toolbox for rational thinking, a kind of software for future generations of natural philosophers. They asked also, Abelard was the most popular logician and dialectician of his time. For Abelard, it's only through doubt that one can discover the truth. In his treatise, Sic and Non, he cited 158 contradictions found in the scriptures and the fathers of the church. He gave Western thought the first discourse on method and refined the notions of differences between such concepts as opinion, faith, and truth. William of Ockham continued investigation of logic and reason, setting the method of search for truth. One of his most widely known conclusions was the so-called Occam's razor, meaning the rejection of unnecessary concepts and assumptions. A working theory should have few axioms and many phenomena explained, and not vice versa. And I would just like to underline that even, here you have the fantastic example of Occam's razor in action. In Ptolemy's system, geocentric system, he needed 55 epicycles in order to describe the motion of planets. Now, when Copernicus made his heliocentric system, he reduced the number. Of course, his orbits were not elliptic, but circular. So he had also to add epicycles, but he was very proud that instead of 55 epicycles, his system needed only 30 epicycles. And then came Kepler and with 0 epicycles, because he discovered that the orbits were elliptic and not, but Occam's razor, I think that it is still needed even now, because when I hear the theories of multiverse, as if our universe was not big enough, and there's infinite number of extra universes, but somehow we cannot observe them, or that we are living in a 26-dimensional world as a membrane or something like that, then I think, very often I think that Occam's razor would be welcome. Now I just wanted to mention 2 other important thinkers, medieval thinkers, Roger Bacon and Thomas Aquinas. The next generation, both were religious men and left invaluable imprint on European thought. Roger Bacon was a disciple of Robert Grosset. He was a Franciscan rector of the Oxford University, then Bishop of Lincoln. He is credited with invention of glasses, correct and short-sightedness, and a threatened optics. He continued his research in optics and was the first one to describe correctly the functioning of human eye. Of course, he made his experiences on animals' eyes. St. Thomas Aquinas authored the extraordinary Summa Theologiae, a next step after Abelard towards rationalizing the faith. He rightly deserved the name Divine Doctor. The following quote illustrates Aquinas' thinking. If only a single grain of sand was annihilated, the entire universe will fall down. And this is somehow like some premonition about the rule of conservation laws, which we know today and which are absolutely, as Thomas Aquinas predicted, that there's no way of annihilating energy of even annihilate masters, equivalent of energy that is made. Now I move to more modern thinkers. René Descartes, who somehow ended the controversy between the nominalists and the idealists, whether the world is real or not. And he said that just a common sense, if we are discussing and thinking, that is a proof of our existence. You don't need anything more. But just next generation, George Berkeley, who was also a bishop, and he asked a question. He questioned Descartes' statement, saying that, okay, if thinking is the proof of existence, what about the non-thinking subjects and objects? Do they exist or not? And his answer was that only a thinking observer can draw the conclusion. This in turn led to the question of agreement between different observers. How can we be sure that their observations can be interpreted in the same way? One of Berkeley's conclusions was that even an accelerated motion cannot make sense if no other material objects existed in the universe. This point of view was later adopted by Ernst Mach and greatly influenced Einstein in his investigation of general relativity. The notion of different observers and how to make how the agreement between observation. This comes from Berkeley. Now I would like to, this is another digression, which I call a lesson of humility. It seems ironical that the only tangible messengers of cosmos, this is something that happened in 19th century in France, in 18th and 19th century in France. So the only tangible messengers of cosmos accessible for scientific scrutiny, including their physical and chemical properties, were steadily denied cosmic origin. That meteors were interpreted as atmospheric phenomenon is not strange. After all, they really burn in higher atmospheric strata. But the meteorites were continuously believed to be of volcanic origin. It is less easy to explain, but many ancient men of science repeatedly expressed this view, including Aristotle, whose authority remained unquestionable for more than 15 centuries. On July 1790 at 9 p.m., a huge meteorite fell in the vicinity of Barbotan, a town in southwestern France. The fall was seen by thousands of people. The mayor of the city gathered a declaration of about 300 witnesses and sent the report to the Royal Academy in Paris. The members of the distinguished institution did not believe in the possibility of stones falling from the skies. The renowned chemist Claude Berthollet wrote on that occasion the following: "How sad that the municipality produces a protocol containing popular fairy tales, pretending that this really happened, while no physical reason for such an event can be given, nor by any reasonable cause." Here is Barbotan, and very luckily enough, that just 13 years later, there was another, really a rain of meteorites, which happened in Aigle. Aigle, it is in Normandy, in April 1803, already after French Revolution. And the Royal Academy was now named the French Academy. So on April 26th, a huge meteorite fell in the vicinity of Aigle. And not only meteorite, it was it fell into pieces. So there were many pieces that fell. In contrast with what happened in 93, the Minister of Interior, Chaptal, ordered Jean-Baptiste Biot, when a young member of the Academy of Sciences, to investigate the veracity of the event on the spot. Biot spent 10 days gathering information, asking dozens of witnesses and ensuring that they did not know each other and never met before or after the event. It was like a genuine criminal police investigation, and when Biot returned to Paris, he succeeded to convince his colleagues that the meteorites are indeed of extraterrestrial origin. But the final verdict was expressed by the jurists and doctors of law, who confirmed after analyzing the interrogations that according to their science, I mean the lawmakers, the lawyers, Biot conclusions should be considered as objective truth. This is the example how the humanities, I mean the law, can finally give the way to what is objective truth or not. But there's another caveat I would like to say. This is to beware of the consensus. This is the example of what consensus can mean. In 1931, there was a collection of anti-relativity essays, originally published in German, 100 Autoren gegen Einstein, under the title 100 Autoren gegen 100 authors against Einstein. And it was mostly directed against Einstein's relativity theory. They ignored other contributions by Einstein. And what is amazing is that there are even 2 Nobel Prizes among these 100. Stark and another one was, his name was, I forgot. The one of Leonard, the one who also got Nobel Prize on photoelectric effect, but for discovering it, not for explaining it. It was explained theoretically by Einstein by introducing the notion of photon. So 100 people were needed to refute Einstein. And by the way, the anecdote says that when Einstein was shown this book, he said that, well, if I'm wrong and they are right, one author would be pretty enough. You don't need to write 100 or 1,000. So the consensus doesn't mean that much. Now I turn to the epilogue to give my feelings about science in general and our place in the world. The size of the universe conceived by ancient civilization was quite modest by our standards. The maps of the world found on clay tablets do not go beyond a few thousand kilometers. Ancient Greeks' ecumene, or inhabited world, was limited to parts of Europe, Western Asia, and Northern Africa. At the end of antiquity, Earth's size was known quite well. It took about 2 millennia until the size of the solar system was firmly established. The corresponding cognitive leap represents 6 orders of magnitude on the logarithmic scale, from a few thousands of kilometers on Earth to 5 billion kilometers, including the orbit of Uranus. Great as this was, it became still conceivable to the modern human mind. The enlargement of the observable universe that resulted from the development of astronomy during millennia was accompanied by the parallel increase of estimates of the age of Earth and the solar system. It can be illustrated by the following list of sizes and distances. So you see, at the end of 18th century, with Uranus, it was about 37 astronomical units across. Kuiper's belt, which is far beyond Pluto, the 7 light hours. 1 light year is 63,000 astronomical units. Astronomical unit is the distance from Earth to the Sun, which is about 150 million kilometers. The closest star is 4.37 light years away. 1 parsec is 326 light years, and the kiloparsec is 3,000 and more light years. Our galaxy diameter is 27 kiloparsecs. The closest great galaxy is 10 to 5 light years across. Distance is 778 kiloparsecs. The Virgo cluster is, again, is 2 orders of magnitudes. It is 65 million light years distance. And cosmic backgrounds goes into 10 of billions light years. So it is beyond our understanding, beyond our imagination. How deeply the ever-growing scale of the universe influences our perception can be illustrated by the following 2 comments. The first is taken from the general scholium, which closes Newton's Principia. The most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being. For Newton, there was no doubt that all has some meaning and that there was a creator, which is much more intelligent than we are, that created all this. Now, about 300 years after Newton, the second quote comes from Steven Weinberg, from his book, The First 3 Minutes. This is a book on cosmology and the Big Bang. And it is very pessimistic. He says, the more the universe seems comprehensible, the more it also seems pointless. It's very sad. Here's Newton and Weinberg. However, my opinion is that one should not let oneself be discouraged by such pessimistic statements too much. Because after all, if the universe, our existence, and all our actions were really pointless, this would also apply to Weinberg's remark as well. Everything is pointless, even the remark about pointlessness. So although we still don't understand the goal, does not mean that there is no purpose at all. It might be that we don't even know how to formulate such questions properly. Seemingly impersonal and neutral laws governing physical reality do not imply that we cannot find meaning and sense of our own existence. But I'm just quoting The Black Cloud. It's a science fiction novel written by Fred Hoyle, which makes a hypothesis that there are other intelligent beings, but completely different that in composition that we are. They're more like black clouds of organic matter on dust. So perhaps the search for a purpose is the ultimate goal. The universe could have existed without us, but we could not be there without the universe. So if we find the meaning of our own existence, the entire universe will acquire meaning and purpose in our eyes too. This is to say that sometimes I feel that it is a little bit preposterous to ask of what is the sense and the goal of this huge universe by beings who don't know exactly what is their own meaning and purpose. And here is my last transparency. It is a very beautiful painting by Paul Gauguin, which is epitome of human existence, birth and death. And he gave a very curious title to his painting. It was painted in Tahiti. Where do we come from? What are we? And where are we going? So these questions are still open, and only humanities probably can give some clue or answer. And exact scientists are helpful, but they cannot have the ultimate word. So thank you for your attention. This is all.